In this video, we're going to be going over how to mill the CAD tutorial part that we made in the previous set of videos. Now, before we get started, the first thing we have to do is define what job we're actually starting with. So we need to go over either to the CAM tab up here and start a new job. There's also a way to get into it right here on the quick access toolbar, or we can right click on CAM defaults and say new job. Now, when we open up the new job section, it's going to let us pick our job type. So we're going to choose either milling, turning, mill turn, or wire EDM. I'm going to go ahead and choose milling, and then I'm just going to use the BC3X mill. It is a generic 3-axis machine, so it'll work the way I need it to. And I'm going to go right down here to the stock wizard, and this is where we get to define the stock. Now, when we go directly into the stock wizard, it always asks us for a workpiece. And the workpiece is a solid model that represents the final finished part. And what we can use this for later on is when we launch the simulation, we'll be able to see the finish that comes out in this part. And then through that workpiece, we can actually turn it on and off and compare the part that we cut in the simulation to the part that's drawn, which if drawn correctly, this should be the perfect part file. So I'm going to go ahead and just pick my solid model there and then hit next. And right here, it's going to let me choose my stock. Now, the stock type I want to use is just going to be cylindrical stock, just like this. And then I'm going to say bounding cylinder and then calculate stock. And it's going to automatically calculate that cylindrical piece of stock for me. Now, what I want to then do is I want to add some material down on the bottom as something that we can hold on to. So that'll be my end face. I'm just going to add a 1/2 inch worth of material there. And we'll see that we add an extra 1/2 inch. And then for the start face, I'm going to go and add an extra 100 thousandths as material that I'm going to face off. And then I'm going to say that I'm starting with a 6-inch diameter piece of stock. So it is pretty squared up there. From here, I'm just going to go next. And then for my origin, I'm just going to pick the top dead center right there. Now, as a reminder, inside my settings, I currently have under the CAM settings, auto blank new items. So that's why my stock just disappeared automatically. Any toolpath or any stock that I create is going to automatically disappear as I create it. So just want to make sure that we have it kind of the way we want. Make sure you have those settings the way you're going to want. So I'm going to scroll down to the bottom, and then because I have the Simulation Pro, I can see a copy of my machine inside my simulation. So what I want to do is I want to lift my part up in Z. If we go back a page, we could see that the height is 3.5 inches, but we also have that 1/2 inch of stock sticking out the bottom. So when I go next, I'm going to just make this stick out. You could do 4 inches would be perfect. I'm going to go 4.5 inches in Z, and that's just going to lift my part up in my simulation. This does not affect the code in any way. Right here, I have my clearance plane, which is the area above the part that I'm going to rapid my tools around in. So then when I'm done with that, I'll just hit OK. I'm fine with 1 inch on the clearance plane. Now, after we have that done, the next step is kind of up to you. You could go in and create your tool crib, or you could create your tool crib as you go along. So I'm going to do a little bit of both. For the drills, I'm going to let BobCAD make those up as we go along. I'm not going to add those to my tool crib right now. But I am going to go ahead and right-click on the milling tools here and then go down to the tool crib so I can add in the few tools that I plan on using. So under mill, I'm going to go to end mill rough. So in the category on the left, I'm going to scroll up. And first, I'm going to start off with the center drill. Now, like I said, I'm not going to pick the drills, but I am going to pick a center drill for BobCAD to use. I like to use my 1/2 inch 90-degree spot drill right there. And so I'm going to pick it. If I need to modify it, like change the material, in my case, it's set up as carbide. But if it was high-speed steel, this would be my chance to modify the material. And this is one of the big benefits of setting up a tool crib before you start your job, is you can go in and make changes to these tools and anything you need. So I'm not going to change it. I'll just hit OK. And we'll see there's our center drill, our spot drill. And then I'm going to use an end mill rough. So I'm going to add from the tool library. I'm going to sort by my diameter. And then I'm going to scroll down until I find my 5/8 flat end mill long. And I'm going to click on that one. And then again, if we scroll over, we'll see that one is carbide. So I'll go ahead and hit OK. And that's good as well. I'm then going to go down to my end mill finish and add from my tool library. And this one's going to be a 1/2 inch carbide end mill. So I'm just going to sort by my diameter. I'm going to go find my 1/2 inch flat end mill long, but I'm going to double click on it so that I can get the parameters to open up so I can change this from high speed steel to carbide. And then I'm just going to click on it again and hit OK. Now we have a carbide 1/2 inch flat end mill. And we're just going to use that one for finishing. And then the next tool I want to add in is, again, another end mill finish. And it's only because the end mill finish category has more ball mills in it by default. So I'm going to add from my tool library, sort by my diameter. And once again, I'm going to go down to the 1/2 inch section. And I'm going to choose my 1/2 inch ball end mill. Again, I could double click on it, change the material to carbide, and then hit OK. And now I have my 1/2 inch ball mill in there. And I can change the length of it later on. If something's wrong here, I can fix that later on. It's not a big deal. And then finally, the last tool I'm going to add in right now is just going to be my chamfer mill. So I'm going to say chamfer mill, add from the tool library. And I'm just going to go ahead and pick my 1/4 inch chamfer end mill here. And if I scroll over on this one, we'll see it's high-speed steel. If you're using an inserted chamfer mill, you can go in and change it to insert. In my case, I'll just leave it as the high-speed steel and hit OK. And there is my little chamfer tool. We'll notice there's a flat bottom to it. That will come into play when we do our chamfer. When I'm all done, I'll hit OK. And that's it. So the first thing we need to do is face off the part. We need to take that 100 thousandths off. So I'm going to use my 5/8 tool to do that. You could use a 1 inch tool, 2 inch tool, 3 inch tool, whatever you want to use. You could do it. The steps are going to be the exact same, and that's probably a little bit faster, but I didn't add one of those tools in. So I'm going to right click and just say mill facing. With mill facing, I don't really need to select any geometry. So there's nothing I need to pick right here. It's recognizing that 100 thousandths and it's recognizing the stock. So I'm just going to go next. Right here, we can see it drew a circle for us. That is the stock. So we'll go next again. For the strategy, all we have in here is facing. So I'll go next again. Right here's my posting tab. So no changes there. And then next we have our facing tool. So we'll see it did grab my 5/8 flat end mill. Now, normally at this point, we'd come over here and we would set up our feeds and speeds. And we'll look at the material as soon as we compute this toolpath. But at this point, if these feeds and speeds are not right, you're going to want to modify them so they are right. So either change the surface footage and the chip load, or you could just type in the spindle RPM, the cutting feed rate, and the plunge feed rate. For now, I'll leave the use system feeds and speeds checked. Now, right over here, we have our tool number. Do not worry about the tool number right now. We can renumber all the tools at the end of the job. Right now, the way it's going to work is the first tool that's used is going to be tool number 1. The second tool that's going to be used is tool number 2. If that's not how it works on your machine, or you have different tool numbers, then you'll be able to change them later on through the verify tool assignment under milling tools here. Right here, we just have our spindle direction, clockwise or counterclockwise, and then our coolant type is flood, mist, air, or oil. From here, we'll go next, and we have our patterns. So we have a zigzag where it just goes back and forth, and with zigzag, we can tell it to go off the workpiece or stay on the workpiece. We have a zig, which just keeps the tool moving in one direction, or we have an adaptive, which keeps the engagement on the tool consistent as it cuts. So I'm going to go ahead and use adaptive, and I'm going to set my step over to 60%. From there, we just have to choose whether we climb or conventionally mill this. I'm going to choose a climb mill and then go next. Right here for the parameters, if we were leaving material for maybe another finish pass to clean up, then we'd set up a bottom allowance. In my case, I'm going to leave that at 0. And because I'm only taking off 100 thousandths, I'm not going to make any changes. I'm going to leave it on single step. Now, as far as leads go, I'm going to go with some parallel leads. And the rule of thumb that I follow is at least half the tool, but preferably more. So my tool's 0.625. So I can actually type that in and then divide it by 2, and it'll give me the result. But in my case, I'm just going to say 0.4 and make it a little bit bigger. Next, we have our links, which in this toolpath, we don't really have any linking modes because this kind of links to itself, as we'll see here in a second. So really the only option we have is if there's a gap in the geometry of, by default, 200% of the tool diameter, then we'll rapid retract and relink. If there's no gaps in the geometry like that, then we don't have to worry about it. So we'll go next again. And right here we have our advanced feed rates. We're not going to change anything for the convert rapids to feeds. That's for dogleg rapids that happen on some machines. And then right here we have a lead in and lead out feed rate percentage. So it's a percentage of the feed rate used only when leading in or leading out. And I'm not going to use that either. So when I'm all done, I'll hit compute. And then I can wait for it to calculate. And there is our toolpath. And what we'll see is it's already blanked out. We just don't notice it because it did select that final facing feature. I like to blank out the features so they don't get in my way. The way that you can look at your features afterwards is just by clicking on the individual operation of the feature. So if you have multiple toolpaths, you can click on each individual one. All right, now we're going to go ahead and shrink that up. And the next thing we're going to do is we're going to take off the material down to this floor. So to do that, the easiest way is to use a 3-axis toolpath. Now it all depends on how we want this to work, but if I don't want my 3-axis toolpath to cut inside of this area, then we would actually go in and modify it so it doesn't cut in there. We would actually put covers over that, or in our case, we could actually right-click on the extrusion that we made when we did it, which is these guys here, and say suppress those. And what that's going to do is it's going to hide them completely. And as long as we pick our geometry when these are turned off, the tool won't try and machine into those. So that's what we'll do. We'll leave it like that. That way we can do those pockets as just simple 2-axis pockets. So we're going to go down to our cam tree, right-click on Machine Setup 1, and then I'm going to go down to Mill 3-axis. Now in here, the first thing this asks for is for us to select the geometry. So I'll say Select Geometry. I'm going to drag a box over the whole part, and then I'm going to hit OK. Now the other thing it asks for is a boundary, and I actually don't want a boundary on this part, but if we were to pick a boundary, the boundary is used to contain the toolpath in a certain location. So I could say I want it to stay inside of that circle there. And if I set up that as my boundary, the toolpath will not go outside those edges. But like I said, I don't want a boundary because I do want the tool to be able to go over this edge and give us a nice clean finish. So we'll just hit OK and then go next again. Right here we have our feature page. So we have our clearance plane at 100 thousandths. Our rapid plane, or the area in which we're going to rapid across the part, not clearance above the part. So basically a rapid is going to be inside of its own feature. If we have to make a cut and then move to another area to continue cutting, we're going to use the rapid plane. And then we have our feed plane. The feed plane is used to tell BobCAD where to start feeding from. So if we had to set our rapid plane at, say, 1 inch, the feed plane would still ensure that we feed from 100 thousandths above the top of part instead of 1 inch. So that way we don't have to wait for the plunge feed rate to plunge through air on its way down the part. The top of feature is set to 0 now, because it's not seeing the 100 thousandths that have been faced off. So technically the top of part is 0.1 or minus 0.1. And we can actually say pick top and pick just an edge that represents the top here. And we'll see that the top is minus 0.1. And that's because we've already faced off 100 thousandths. So we'll go ahead and hit next. Right here for our machining strategy, we have a Z-level rough. And then I'm going to go ahead and add in a Z-level finish from the available operations so that I can do them both at the same time. The Z-level rough and the Z-level finish, they specifically work really well when they're doing the walls of a part. So the last toolpath I'm going to add, which is part of the Pro toolpaths, is a Flatlands toolpath. And I'm just going to move that over. So we're going to rough it out with the Z-level rough. We're going to finish basically the walls with the Z-level finish. And then we're going to use a Flatlands to go in and clean up that floor a little bit more. So we'll go ahead and say next again. For posting, the only thing I'm worried about is the work offset and the arc fit. Work offset is whether or not I'm using G54 or G55, G56, or so on. Number 1 is your first work offset. So in my case, that would be G54. 2 would be your second work offset. So you're just going to make sure you set it up for the work offset you're using. And then I'm going to turn on arc fit because this ensures that I have arcs in my G-code program. From there, I'll go next. For the roughing tool, that's exactly it. I want to use my 5/8 flat end mill. And again, we would normally at this point set up feeds and speeds, but I'll go ahead and say next again. For the patterns, we get to choose whether we're pocketing from the outside inward for a pocket in or the inside outward for a pocket out. So I'm going to go ahead and leave it on pocket in with a climb mill and then go next. For the parameters, I'm going to set up my depth of cut at, we'll go a little bit under half my tool diameter. So we say 0.625, and then I'm going to divide that by 2. So we have a 0.3125. I'm going to keep that a little bit under halfway, just so I'm not running right at 50% on the tool. And I'm going to do that for both these. So 0.3 on the depth of cut, 0.3 on the step over. The allowance right here is the amount of material we're going to leave sitting on the part for the finish tool to clean up. So for this one, I'm going to go ahead and set it to 60 thousandths, so 0.06. Get rid of that double decimal because it'll give us an error. The machining tolerance is the overall quality that this part's going to come out looking like. It's the tolerance of the path that gets created. It's the allowable deviation on a job. So this is how much the tool's allowed to kind of wobble as it cuts in a straight line. I have it set to a 1/2 thou, which is the default. If your tool paths are taking a really long time to calculate and the surface finish is already pretty good, you can try and turn it down to say 5 thousandths. That's going to calculate it faster, but it's going to give you a worse tool path. The other option is to make it smaller. So bring it down to a 1/10. This one's going to calculate longer, but it will give you a better tool path. So it is kind of worth it in some scenarios. I'm fine with a 1/2 thou. It's a pretty good median right there. We don't really have to worry about the finish. It's going to come out really good based on really the depth of cut and the step over we set up. I'm not going to set any top and bottom of job right now. We may need one after we calculate if it tries to go down the sides of the parts a bit, but for now we'll leave that there and go next. Right here we have our lead. So how are we entering into the material? We can plunge, and with that plunge we could either do a single depth, we could peck our way in, or we can fast peck our way in. We then have a ramp or a spiral, and these kind of have the same settings to them. They ask for the angle of approach between the two of them, so kind of what angle we're working in on, and then the length or the radius. So in my case, I'm just going to set this length here on the ramp entry to a 1/2 inch. So I'll set that right there. The angle of approach is 3 degrees, and then the ramp direction is the axes in which we line up the ramp. So 0 means we're going to line up along the x-axis when we ramp down. So this zigzag is going to go along x. 90 would run along y, and you could use any angle you want. So we'll go next again. For the options, we have some options on cutting extents, whether we cut everything, just the innermost geometry or the outermost geometry. In my case, I'm going to use all because I want it to cut everything. It might even go in and cut this hole, and I don't really want it to, but might do that anyway. So I'll go next again. Right here we have our advanced feeds, so no changes there. And then for the Z-level finish, this is going to use my finish tool, which is my 1/2 inch ball mill that I created. Now again, if we created this tool, we brought it in, we could change anything about it right now. But to make it a ball mill, you need to make sure that the diameter and corner radius match up, meaning the corner radius should be exactly half of the tool diameter, and that's what's going to create a ball mill in BobCAD. So we'll go next again. We have our patterns. This one doesn't really have much. It's got just climb or conventional mill, so I'll say climb. For the parameters, we get to tell it what our finish pass needs to run at. And so we want to give it something small enough that the cusp that's left over is non-noticeable. So I'm just going to go with just 20 thousandths. You could go with 50 thousandths as well. The finish is probably going to be decent. But if I go with 20 thousandths, I could get an even better finish on there. It's just more passes on the part. If you're stuck for time, you don't want to run a super long running part, then go with a larger depth of cut because that's going to leave a larger cusp between your passes. The allowance for X, Y, Z in this case is going to be 0. I want to finish right to where my surfaces are drawn, and we'll leave it there. No top or bottom of job, and then we don't need to skip the first cut. So we'll go next again. For the leads, I'm going to leave it on plunge, and I'm just going to go with a single depth. And then for the lead in, I'll just go vertically. But you could go parallel, you could do a right angle, or you could do a circular lead in as well. Right here we have our options. Again, innermost or outermost, I'm going to leave it on all. are processing by area, meaning we finish an area before moving on to another, or we could go by level where we take everything down at the same level. I'm going to go by area. And then we could calculate from the tool tip or the tool center. So where is the G code based on? The tip of the tool or the center of the tool? I leave it on the tool tip. Next, again, we have our links. So how do we track down the part when we connect from one pass to the next? We could either say follow the surface, go horizontal then vertical steps, a spiral, a retract, or an S-link. I'm going to go ahead and go with follow. And then right down here, it's asking what happens if we run into our boundary. Do we follow it back around or do we retract and rapid? This doesn't apply to the part we're doing because we don't have a boundary. So we'll go next again. Right here for the advanced feeds, just the convert rapids and then the lead in and lead out feed rate percentages, which we can ignore. And then when we hit next, we're onto our flatlands. So again, I'm going to use my flat bottom tool. That's the whole point of this toolpath. It's going to recognize the flat areas in the part and it's going to go and cut them. So by leaving those pockets off, we're going to get a nice clean finish around this whole thing, and then we'll be able to kind of add those pockets to it with a 2-axis toolpath. Right here for the patterns, we get to choose whether we offset that shape inward, outward, however we want to do it. We can do a parallel, or we could do an adaptive roughing, which is more of a high-speed machining strategy. I'm going to go with just offset. I'm going to tell it to zig to keep everything moving in one direction so I don't have to come to a stop to change directions. And I'm going to climb mill that. For the step over on this, I'm just going to leave it actually at 100 thousandths. That's perfect. We don't need to go too crazy on this, and 100 thousandths is probably even small for a 5/8 tool, but I want to make sure I get a nice clean finish on that floor. The minimum width of flatlands is the smallest area that we're going to recognize a flat. In this case, it's 50 thousandths. I don't have an area that small anyway, so this doesn't really apply. But we also have a maximum width of flatlands that is turned off by default. The maximum width of flatlands recognizes how big an area is and whether or not you kind of want to waste your time with whatever tool you have. Maybe you're using a 1/4-inch tool to go clean up some smaller areas, but you do have some bigger flat areas. Well, it might be better to switch tools and use a 1/2-inch or a 1-inch tool to go and do those big flat areas as opposed to using your 1/4-inch tool. Right here we have our machining tolerance. It's set to 1/2 thou. And so again, I'm going to leave it there. We have no top or bottom of job, but you'll notice that the allowance moved over here. Now on all the pro tool paths, which is the advanced rough, the advanced Z-level, advanced planer, the equidistant, the flatlands, the pencil mill, and the project curves, all of those pro tool paths are going to have the allowance over here. And it actually has two different types of allowance. You have a global allowance or a allowance across the entire part, which is pretty much how the standard tool paths work. But you also have a side and bottom allowance. So you can leave material on a wall, but not on a floor. And that would have been a really nice feature if we were using, instead of a Z-level rough, we were using the advanced rough. I could have used this 5/8 tool to give us a nice flat floor already and then just have to clean up the walls and kind of blend it in. So I'm going to leave it on global at 0 because I'm not trying to leave any material at all. Right here for the leads, we can plunge, we can ramp, or we can spiral. Again, I'm going to just plunge in vertically. For the options, we just tell it if we had a boundary, are we using the center of the tool to run along the boundary? Are we keeping the tool inside the boundary? Or are we letting the tool go outside the boundary? This just helps so we don't have to modify a boundary in case we need to make it a little bit bigger or a little bit smaller. By default, it's going to offset by whatever the radius of the tool is so that the center of the tool kind of does one pass. So the edge of the tool is what cuts along the boundary. But I'm going to leave it on center of tool. We don't even have a boundary. For some smoothing options, it's just, do we smooth the corners? It's kind of just a smoother interpolation on the cuts themselves. So we could smooth corners, we could smooth the links out. And one of my favorites is remove corner pegs. If there's an area where you're doing usually a larger step over, you can have areas that leave little pegs standing up. So this is actually going to go out of its way to loop, knock down the peg, and then continue on. But we shouldn't need that here. I'm not doing that big of a step over, so we'll hit OK. And then calculate from the tooltip or tool center. Right here for the links, we could either follow the surface when we move along it. We can go with a direct, which really follows the surface, but if there's any gaps, it'll go straight across the gap. We have S links, or we have a full retract. I'm just going to go with follow. And finally, we get gouge checking. This is another thing that you get for the Pro toolpaths. If there's a part of this geometry that I do not want this tool to touch, I can actually select it as gouge check geometry, and BobCAD's going to try and avoid it by whatever allowance we leave. I don't have any of those surfaces on here, so I'll just go next again. And right here we have our advanced feed rate, so we can convert our rapids to feeds, and then we have our lead in and lead out feed rate percentages. When we're all done, what I like to do is actually finish this, because if something goes wrong, I don't want to lose all the work I just put in. So now I'm going to go up to Save As, and I'm going to save this as my mill tutorial here. I'll just save that for now. And then I go and calculate my toolpath. Now at least if something happens, I'm not going to lose everything I did. Now I can right click on where it says Feature 3-Axis and Compute All Toolpath. And we'll be back when the toolpath's all finished calculating. And the toolpaths are done. So as soon as it's done, remember my toolpaths are automatically blanking themselves out based on the new feature inside of the settings. So I can look at them. Here is my Z-level rough cutting its way down. Looking pretty good so far. Here's my Z-level finish though. And the Z-level finish is cutting a little bit too far because I'm starting with stock that has already been, say, turned. I'm just trying to go in and clean up the top here, which we could have turned a lot more than we did, but it's already to size on the side there. So I do not need my tool going down there. And then I have my Flatlands, which looks great. What I want to do is right click on this feature and say Edit. I'm going to go right here to the Z-level finish, and I'm going to go to the parameters page. That's where I can find my bottom of job. Now what I'll do is I'll say bottom of job and then pick. And I'm just going to pick this edge right here and hit OK. And the big thing here is because we went and turned off those slots that were in the model, because those got shut off, I need to try and get all these toolpaths done and correct now. Because if I have to recompute this after I turn them back on, it'll recognize them again. So this time I am going to hit finish. But the reason I hit finish this time isn't so I can save. It's because if I hit compute from that feature, I have to sit through all three of these recalculating. And I only need to recalculate the Z-level finish. So I'll compute that one toolpath. We'll see when it gets to phase 4, we're almost done. And then we will move on to the drilled holes and the slots. And there it is. Now we will see there is some toolpath in the center there. If we wanted to avoid that, the easiest way to do it would be to add a new layer. I'll just call it cover. And then go up to my Create 3D tab and go down to Planar, and just right on this edge of this, just on the top of the chamfer, I could click that and put a little cover over it. Now if I was to go repick my geometry and include that cover, it would avoid that area. So real quick, I'm just going to go in. For the geometry, I'll say Remove. I'll right click on it and say Reselect, drag a box, and hit OK. After that, I'm just going to right click on the Feature 3-Axis and recompute, and we'll be back when it's all done. And there we have it. So there's our Z-level rough, there's our Z-level finish, and if I turn off that cover layer that we had, it is not in the middle there. And then we have our Flatlands. So now what we can do is shrink that up. I can right click on my machine setup 1, and then I'm going to go to Mill Drill Hole. I'm going to pick all 3 holes. So I'm going to pick this center surface that's right there that goes all the way through. I'll pick that center surface as well. And then I'm going to go ahead and pick the middle surface. And we just want to make sure that it knows to go all the way down, which we'll pick that depth here in a second. So for this, we're going to do a standard drill. We got our geometry. We'll hit OK. And then go ahead and hit Next. Now what this is going to create is 2 separate features. So right now we're doing our 3/8 holes, and then we're going to do our 3/4 inch holes. So for the top of feature, I just like to come in and repick this, but I'm just going to say pick top, and I'm going to go right to the top of the chamfer here and hit OK. And then we'll say pick bottom, and I'm just going to flip this over and pick the bottom hole here. And then I'm going to go a little bit extra, which is actually already happening. Now, if we look at the top, we have our group retract. So this is how we retract. So basically just to the clearance plane. We have our rapid plane, our feed plane, the diameter of the hole. And then right here we have whether it's a through hole or a blind hole. Now by default, if you choose through hole, BobCAD's going to add 50 thousandths onto the bottom of the job. So right here, we'll see that the depth is 1.00. When we get to the final parameters page of the drill, it's going to be 1.05 plus the tip length. So I'm going to leave that there and go next. For the machining strategy, I'm just going to choose hole, which gives us a center drill and a drill. And then I'm going to, down at the bottom, say apply to all features right there. And I'll go ahead and hit next. Right here we have our machine sequence, so it's optimized is really the best option. There's only 2 holes that it's doing, so there's no right or wrong way. It's going to machine them. For the posting, work offset number 1. For the center drill, it's got my 1/2 inch 90-degree spot drill that I put in. We could see we're running at our RPM max. That's a 10,000 in my machine. And then for the parameters, we could just tell it where we want to center drill down to. So I want my center diameter to be, let's say, 0.175, and that's going to send me to 0.0875 deep with this tool. So I want the center diameter there, and that will be the depth. We could choose to peck or fast peck this as well, and we'll go next. Now, like I said, I did not pick drills for this feature. This is an automatically picked tool from BobCAD. Any of the drills are going to pop up. You'll see it's just a 3/8 drill. Even if you're picking up a hole that's not a normal size, just kind of a randomly sized hole, BobCAD will create a drill that fits it to a T. So if you do need to change the tool, you can actually go into the tool crib. I could go pick whatever diameter tool I want right now, as long as BobCAD knows it. We're going to get the right tool path for it. It's kind of, even though this is for a 3/8 hole, a 3/8 hole and a 1/2 inch hole is the same tool path. It's just a different tool. So we'll go next again to the parameters. And this is where we see our effective depth. So the effective depth is the depth at which we're going to get a full width cut. The overall depth is where the tip goes. So I'll leave that on cutting conditions there. We could modify it if we need to. And then I'm going to tell it to peck this one out. And then we could use the peck that's in here by default, or we can override our auto peck and actually go in and set it up differently. Right now it's using 50% of the tool diameter per peck. Next, we have our 3/4 inch tool. So again, we want to go say pick top, and then I'm going to rotate this around, and I'm going to pick the top edge of the hole, hit OK, and then we're going to say pick bottom, and I'm going to go ahead and rotate this and pick the bottom edge there and hit OK. From here, pretty much the same steps. Just going to next my way through. We got our center drill and our drill. Machine sequence, it's only 1 hole. For the posting, no changes. Center drill, same tool. Parameters for this center diameter, I want it to end up at 3/8 of an inch. So I'm going to say 0.375, just like that. So we're going to go 187 thou deep, and I'll just single depth that. Right here's my drill. It's a 3/4 inch drill, and next again. And right here, there's our total depths for everything. And again, I'll go ahead and peck that one out. When I'm all done, I can hit compute, and that's going to be a real quick tool path for those two. Now what you'll see is that this rapid line is going through the middle of the part, and that's because of our rapid plane. It thinks the top of the part's right here. Really, it's up here. So to fix that, we could actually right-click right here on our 3/8 feature hole and say Edit. And then for our grouping, right down here, right now what's happening is it's grouping these 2 holes into 1 feature. What I'm going to do is I'm going to separate this feature into 2 separate holes. It'll still work like a CAN cycle. It's just going to return much higher. So I'll just say break that hole group. Now it's going to use the clearance plane off the top of the part. And so I can go ahead and hit compute again. And then if we look at the drill on that and the center drill on that, they are going up and over the part to get to each other. And finally, we have our 2 pockets. And I'm actually going to use the wireframe geometry. It's the reason I left it on this whole time. And I'm actually going to turn off the main solid for now so that we have a real easy pick for that geometry. We're going to right-click on Machine Setup 1 and go down to Mill 2 Axis. And then we'll select our geometry. And for the geometry on this, I'm just going to hold Shift and pick both of those shapes. Now, what we'll see is it floats way high above the part. If we look at the solid model, that is not the right geometry there. So what I need to do is go and say the top of the part is here, just like that. And if we remember from the video we created, the pockets themselves are 3/4 of an inch deep. But what I'm going to do is I'm going to select that here in a few minutes. I'm going to set that depth again by picking it. So I just hit OK, and I'll go ahead and hit next. Right here we have our top of feature, our total depth, and I'm going to say pick bottom again. So I'm going to go to my CAD tree, and I'm going to right click on my extrude cut and say suppress unsuppress, and that's going to turn them back on. And I could have done this a minute ago, but this is another way to pick the bottom of job. So I'm just going to pick that edge right there, go back to my data entry, and then hit OK again. From here, I'll just go next. It's 3/4 of an inch deep, so we'll go next. Right here, we're going to choose pocketing, which is going to give us a pocket with a profile finish. Next again. No changes. We're not adding any tabs. We're not keeping this part held to anything. Our posting, no changes there. So right here we have our 5/8 tool. It automatically picked it. We'll go next again. For the patterns, we have a choice of doing a standard pocket, which does not allow for open pocketing. That's really the only difference between standard and advanced, plus advanced has a few more options. But we have parallel. We have an offset pocket out, so start from the inside and work our way out, and offset pocket in from the outside in. Under advanced pocket, we have parallel, offset pocket out, offset pocket in, morph spiral, and adaptive roughing or high-speed machining. In this case, I'm just going to go with an offset pocket out, but I'm going to set my step over down here to 30%, so we're not being too aggressive and running right down the center of the tool. 30% is what I'll run at. Plus, this is a pretty large tool for a slot that's only 150 thousandths larger, 125 thousandths larger than it. So I do want to kind of keep it as light as I can. Right here, we're going to make sure to climb mill. Go next again. For the parameters, I have my side allowance at 15,000. So that's what I'm going to leave on the walls for the finish tool to clean up. And then I have a bottom allowance of 0. So we're going to finish to the floor. Right here, we have multiple steps. So I'm going to take this out in 3/4 inch passes, like so. I'll go next again. Finally, we have our leads. We can plunge, we can ramp, or we can spiral. I'm going to go ahead and ramp my way in. The ramp length, I'll leave it 1/4 inch. That's fine. That's just the size of the zigzag, so it'll be a real tight zigzag on its way down. Next, again, we have our machine sequencing. I like to leave it on optimized because it lets BobCAD choose the most efficient path. Right here, we have our links. How do we connect from one pass to another? This is all 2D, so I'm going to leave it on direct and direct. Right here, we have our advanced feeds. So we can convert rapids to feeds. We could do a linking feed rate. So anytime we're doing linking moves, we could change the feed rate. We have volume-based adaptive feed rates as well as a corner slowdown. So we could slow down when we enter into a corner. Next, we then have the finish pass. It grabbed my 1/2 inch ball. I'm going to go up to the tool crib and I'm going to choose my 1/2 inch flat end mill and hit OK. And then go next. For the patterns here, I have a standard pattern. This is just going to go around and finish the 15 thousandths that's on the wall. So we have a choice of compensations. We can let BobCAD do all the compensating, which for me is to the left because I want to use a climb mill. So I have a left side, a right side, or off. I like to use left, but I also like to use machine compensation, which gives me a G41 in my code. So I'm going to use that there. I'll go next. Right here we have our parameters. So we have our side allowance, bottom allowance, and then depth of cut. We're going to do just the full 3/4 of an inch in one pass. So we'll go next again. For the leads here, I'm going to go with a plunge lead, and I'm going to do a circular lead in and lead out. Now I do need to make sure this is small enough to fit in the area, but not so small that we can't apply our compensation if we were to use it, because it's during this lead-in move that it's going to use the compensation. So I'm going to just set this to 1/8 of an inch for the length and 1/8 of an inch for the radius. My tool's already compensated for, so I'm not worried about the tool plunging down on the part. I'm worried about my G41 having the time to actually go in and do it. Right here we have our corner types. No changes on that really ever. Right here's our machine sequencing. Again, I'll do optimized. And finally, the advanced feed rates where I can say compute. And there they are. There's the rough pass, and there is the finish pass, which the main thing I'm looking for when I'm looking at a finish pass is to see if this is outside of that green in any way. That's my tool path. This is my lead. If this is over traveling on that, or if it's too large, then we could have a problem. And then the last thing we need to do is chamfer all of these edges. So for this one, I'm going to just create one for these 2 pockets, and then I'll do it for all 3 holes. So I'm going to right click, go down to my Mill 2 axis. Again, I'll select my geometry, and the geometry for this one's going to be the same. Same exact piece of geometry, same top apart. So there's my top apart, and same really depth, but it doesn't matter. I'm going to leave it at a 1/2 inch because when we do a chamfer mill, so we'll go next again, we actually have a separate depth from everything else. So we'll see that here in a second. We'll next our way through. Right here we get to the chamfer mill. There's the 1/4 inch chamfer end mill I made. For the patterns, I'm going to use my comp, and I always like to have a G41. Right here's the parameters. So we can see our cutter position or the offset that we have applied to our cutter, so we're not using the tip of every tool. We can actually shift it over and cut with the edge. The small diameter of the tool, which we're grabbing from right here on the tooling page. And then the chamfer angle, which again, we're grabbing from the tool page. And we can tell from that page whether this is a sharp tool or a flat tool, so it knows it's a flat bottom tool. Right here we have 3 ways of defining the chamfer: the depth, the length, or the width. I'm going to use a chamfer depth, and I'm just going to set this at 0.031 and then do it in a single step. For the leads, just going to use a circular lead in. Again, I'll use 1/8 of an inch, so just 0.125 by 0.125. Next again, we have our corner types, no changes there. Machine sequencing, leave that on optimized. And finally, the advanced feeds. So for this one, I'll go ahead and hit compute, but what I'm now going to do is I'm going to right click on it and say copy, and then I'm going to right click on machine setup 1 and paste that feature 2 more times. So I'm going to paste it once. It's going to ask if I want to use the same depth. Sure. And then I'm going to go ahead and paste it once again. So paste that feature. And yes, I do want to use the same top and depth. So now for the geometry, I need to make sure that we pick the right top and depth, but the geometry is also important because I'm going to use the solid model for this. So if I right click on the word geometry, we'll go ahead and do the 2 holes first. So we'll do this little hole here, and what I'm picking is the inside edge, and same one over here. So for my top of feature, we're at -1.6, which is perfect. I don't need to change anything there. I'll just hit OK. And then I'm just going to right click on there and say compute. And if the lead is too large, we can look at it and we'll see that's too big for that toolpath. So I'm just going to right click on that feature and say edit. I'm going to go to my leads page and I'm going to divide both these numbers by 2. So I'll say divided by 2 and divided by 2. Now when I go ahead and compute and I look at that one again, we're now within our bounds. And again, you'll notice we're going through our part, and that again becomes the top apart and the clearance and rapid plane. So I'm actually going to go in here and set my rapid plane to 0.2 plus this number. So take away the negative and add it. So I'm going to say plus 1.6, and we'll get a total of 1.8. And again, if I compute that and I look at it, we're now clearing the top. And then finally, the last one's real easy. We just reselect the geometry. We pick that edge right there. And then we have to go and pick our top edge anywhere. Hit OK. And for that one, we should be able to just compute it because we shouldn't have an overlap on our toolpath. And that concludes the video on the mill tutorial from inside of BobCAD-CAM.